Let's go to question number 26. Three thin lenses in contact have a combined focal length of 15 centimeter. When third lens is removed, the combined focal length becomes 60 by 7 centimeter. The third lens is. Now dear students, the combined focal length, we have this formula 1 by f1 plus 1 by f2 plus 1 by f3. In the first case, the combined focal length is 15 centimeter. This is 1 by f1 plus 1 by f2 plus 1 by f3. I says that when third lens is removed, then 1 by this would be equal to 1 by f1 plus 1 by f2. Therefore, this become equal to 60 by 7 is 1 by f1 plus 1 by f2. In order to find f3, let's subtract these equations. So 1 by 15 minus 7 by 60 would be equal to 1 by f3. Now take the LCM, then if 4 by 60 minus 7 by 60 would be 1 by f3. The f3 is equal to minus 20 centimeter. The third lens is a diverging lens of focal length 20 centimeter. Therefore, the answer to question is 3. Let's move to the next problem. A disk is floating on the surface of water in a swimming pool. The water has the refractive index of 4 by 3. A light bulb is placed 2 meters below the surface of the water, the minimum area of the disk, so that the light does not come out from the surface. The question is on TIR, and this depth is given 2 meters, and the light will emerge only from this area. This becomes the critical angle, and we know that sine of the critical angle is 1 upon mu, and mu is given equal to how much? 4 by 3. So sine theta c is equal to 3 by 4. Now in order to find this area, the area will be equal to what? Pi r square. Now, how to find this r? R, if this is theta c, so this will also be this critical angle. So r divided by 2 is equal to tan of theta c. So r is equal to 2 tangent of theta c. We know sine theta c, so we'll try to find tan theta c. So sine theta c is equal to 3 by 4. So this is 3, this is 4, this is theta c, and this become 4 square minus 3 square root. Therefore, tan theta c is equal to this by this is 3 divided by root of 7. So this become equal to 2 into 3 divided by root of 7. So I'll fill area is equal to pi into r, which is equal to 6 by root 7 square, and you solve, this become equal to 16.16 meter square. And look at the option, the first option is 16.16. So answer to this question is the first option. Question number 28 says that light takes a 2 nanosecond to travel a distance of 60 centimeter in vacuum and take 30 nanosecond to travel 6 meter in a medium. The critical angle for corresponding medium is, these are 4 options. The first case is the vacuum. The distance is equal to the speed into time, and if I take in vacuum speed c into t will be equal to distance. In the first case, the distance is 60 centimeter, and c into t, the time is given equal to 2 nanosecond. And in the second case, the distance given is equal to 6 meter, and the time is given equal to 30 nanosecond. If I divide the equation 2 by 1, then v into 30 nanosecond divided by c into 2 nanosecond, this become equal to 6 divided by 0.6. Therefore, v by c is equal to 12 by 18, but sine of theta c, the critical angle, is equal to 1 upon mu, and this is equal to this one. So if I fill the value 12 by 18, which is equal to 2 by 3, sine of theta c become equal to 2 by 3, or theta c is equal to sine inverse 2 by 3. And look at the options. The option 4 is sine inverse 2 by 3. So answer to this question is the fourth option. Let's move to the next problem. The question 29 says, in a displacement method, there are two positions of a lens for which we get real image of one pin over the other placed at fixed distance. The first position of the lens is at 45 centimeter from the object, and the second position is at 90 centimeter. The focal length of the lens is. Now dear students, let's see the solution to this question. This was the convex lens. The object was at distance of 45 centimeter from here, and it forms the image somewhere on screen, the real image I1. Now it says that this lens is moved further when from the object this distance is 90 centimeter. Then again you get the image on the screen. And we know that in lens displacement method, u and v are interchangeable. So if this is 45, then this distance would be 90 centimeter. And in reverse, when this is 90, this would be 45. So u become equal to 45. Then your v will be equal to 90 centimeter. And to find the focal length, the formula 1 by v minus 1 by u is equal to 1 by f. Using sign convention, v is equal to 90 and here u was equal to minus 45. So LCM is 90. So 1 plus 2, so this is 3 by 90, or f comes to be 30 centimeter. So answer to this question is option number 2. Let's go to the question number 30. Two identical thin plane concave lenses, a refractive index of 1.5, each have radii of curvature 30 centimeter and are placed in contact with the common axis as shown in the figure. If the intervening space is filled with oil of a refractive index 1.8, then the focal length of this combination will be. Now dear student, it is a combination of the three lenses. One lens is like this, and the second is in between, the biconvex, and the last is again this lens. Now the total, the focal length will be by the formula that 1 by f will be equal to 1 by f1 plus 1 by f2 plus 1 by f3. Now how to find f1? 1 upon f1 is equal to mu 1.5 minus 1, 1 by r1, 1 minus 1 by r2. R2 is equal to how much? R2 is given 30 centimeter. So this is minus 1 by 60, and likewise 1 by f3 is equal to 1.5 minus 1, 1 by r1 is equal to 1 by 30 minus 1 by infinity, it is equal to minus 1 by 60. And to find f2, 1 by f2 is equal to mu 2. This lens has the refractive index of 1.8. So 1.8 minus 1, 1 by r1, 1 by 30, 1 by 30 with minus sign. This value comes to be 1.6 divided by 30. Now fill in the first one. So 1 by f is equal to 1 by 60, 1.6 by 30 minus 1 by 60, and solve. You get the value of f equal to 50 centimeter. And the option to this question is answer number 1.